Hello class, today we are going to talk about the area of polygons. Now most of this honestly is going to be review, but there are a couple of things that you may not have seen before and some things that are probably completely new. So here we go. First off, get a little bit of definitions. Remember, perimeter, that is the distance around a two-dimensional shape. In order to find perimeter, you just add up all the sides. All right, distance around the shape, all the way around the shape. Area is the space occupied by a flat shape or the surface of an object. Okay, so area is this on the inside of the shape, and that formula depends on the shape. Honestly, there's not just one formula for area like there is for perimeter. So let's take a look at some of these formulas, which should be reviewed. You should know most of these. So area of a parallelogram, base times height. And so base is just one of these bases. The height, remember, is perpendicular to the base. All right? And honestly, every single area formula is based off of this right here, based on the parallelogram. For example, rectangle, also base times height. Why? Because a rectangle is a parallelogram. It's just a special kind of parallelogram where the base and the height are both sides of the shape, whereas over here the height is not one of the sides. Okay, the height is the distance from one base to the other base. We also have area of a square, that's side squared, which is really nothing more than base times height, except that both the base and height are the same, and so it's just side squared. Then we have the triangle, 1/2 base times height, because if you look at this triangle, it is half of a parallelogram. Every triangle is. It's just half a parallelogram, so base times height. Very important, remember that the base and height are still perpendicular to each other, just like they were here. That's what we're looking for. All right. We also have the area of a trapezoid, 1/2 base 1 plus base 2 times the height. And what that is, you notice it's very similar, still base times height, like in a parallelogram, except you have two bases. So this b1 plus b2 times 1/2, that's just taking the average. What's the average of these two bases? And then use that, multiply that by the height. Again, notice height is perpendicular to both of the bases. All right, then we have some that are probably new to you, the kite. This is not base times height. This is 1/2 d1 times d2, where d and d, those are the diagonals. All right, so over here, those are the diagonals of the kite. And this is actually based on the area of a triangle, which is based on the area of a parallelogram. See, it's all based on the parallelogram. So what this does, this is looking at 1/2 d1 times d2. This is the area of this triangle plus the area of this triangle. All right, this half of the parallelogram and this half of the, not the parallelogram, this half of the kite times this half of the kite. All right, because if I just wanted the area of this half of the kite, that would be, using my base, would be d1, and then my height would be just half of d2. And then I'd do it over here, and using half of d2 again, and I'd add the two triangles together, and 1/2 plus 1/2 is the entire d2. All right, so it's just diagonal 1 times diagonal 2 times 1/2. All right. Then for the rhombus, which you'll notice is the exact same thing, because notice the diagonals are both perpendicular in both cases. All right. One thing I do want to point out with area, in every single case for all of these, the things that you're multiplying are perpendicular to each other. d1 times d2, the diagonals are perpendicular to each other. Base times height, the base and the height are perpendicular to each other. In all of these area formulas, you're multiplying perpendicular segments. All right? Every time. All right. This, pretty easy stuff. You've been dealing with this for years, except maybe these two here. So I'm not going to do an example of those. I just wanted to get those all down so that you have them again. All right. What I do want to look at, though, is composite figures. So I have this lovely shape here. This is not on the list, right? This is some weird irregular shape. It is not on this list. I do not have a formula for this. All right. Now I could still find perimeter. perimeter is pretty easy. Perimeter, you just add up all the sides, right? So boom, there it is. 15 plus 24 plus 35 plus 46 plus 37 plus 34 equals 191 inches. Always use your units when you have units. That's easy enough. Notice I didn't use the 10 because that's not the perimeter. It's not on this going around the shape. I didn't use AD as 72 because that's, again, going inside the shape. It's not around it. Same thing with CE. All right, this information here. But how do we find area? Well, that's a little bit difficult. So what we're going to do with a composite figure, we're just going to break this into other shapes and then add those up. So one thing we could do is we could just make it a lot of triangles. Right? Every polygon can be broken up into triangles every single time. So we could do area of this triangle plus the area of that triangle plus the area of that triangle plus the area of that triangle. Sure, easy enough, except there are other shapes that are more efficient. For example, I could do this like so. Now I have the area of a trapezoid and the area of a triangle, and I can just add those together. All right. So we find the area of a trapezoid, which was 1/2 B1 plus B2 times the height. So let's see here, the bases, that would be BC is 24 and AD going all the way across. That's why I wanted AD down here. 72, so 24 is base 1, 72 is base 2. What is the height? The height, perpendicular to the bases. Remember, you're always multiplying perpendicular lines. The height is right here, 10 inches. So we just plug those in, easy enough. Multiply it out. Stick it in our calculator if you like, and there it is, 480 square inches. Now we find the area of the triangle. All right, 1/2 base times height. So we need the base and the height. Those, remember, are perpendicular to each other, so I need this segment here and this segment there. Well, for FD, that's going to be my base. Well, that is part of AD, and AD is 72, AF is 34, so I can just subtract those two and get that. And here I need this bit right there, right? Well, I know that CE is 25, the whole thing is, and oh look, that's 10. This here is also 10 because this is a trapezoid and the height of the trapezoid is 10. So this is going to be whatever's left over. So the base, 72 minus 34, is 38. The height, 25 minus 10, is 15. So we just plug those in, stick it in our calculator, multiply it out, and we get 235 square inches. So I take the area of the trapezoid plus the area of the triangle, add them up, and the area of this whole composite figure is 715 square inches. Much easier to do it this way than this way. All right? Always look for the biggest shapes you can. But if you can't find anything, triangles always work. All right. So we're going to get to one last thing, and that would be area on a grid. Now, still, this is not on our list, right? This is not a trapezoid because I don't have any opposite sides parallel. Clearly not a parallelogram. Not quite a triangle. I do have forged sides there. Not going to work. So I could break this up into other shapes. So with the grid lines, you always want to use grid lines when you can. Makes it a little bit easier to figure out height and things like that. I could do it like this. All right? 2 triangles and a trapezoid. Sure, I could do that. Except there is a formula for this. This is a wonderful thing that I wish I had been taught in high school, but I wasn't. I found this later. This is Pick's formula, named by a guy named Pick. Found this, and it's really cool. This is how this works. Area equals 1/2 B plus I minus 1. Okay? Now, this is only going to work on polygons where all of the vertices are on a lattice point, right, where the lines intersect, right, on the lattice points. Okay, so it's not going to work for something like this, because notice this one point right here, not on the intersection. It's not on a lattice point, so it won't work for that, but it'll work for any polygon where the vertices are on the lattice points. And the way this works, B and I, B are the boundary points. That is all of the lattice points that are on the line of the polygon. So that would be those points right there. All right. I is all of the interior points, every point that's inside the polygon. All right, now you do have to be careful, because notice this point right here looks like it's on the boundary, right? But it's actually just inside. Okay, and the one way you can test this, if it looks like it's there, maybe you just didn't draw it quite right, check the slope. So to go from this one to this point here, from the vertex, that would be up 2 and left 3. If you do it again, up 2, left 3, you're not on the line, which means the slope isn't right. This one's not on the line. It's just inside. All right, so it's one of my interior points, like so. And then all you gotta do is count. So let's see my boundary points. I have 1, 2, 3, 4, 5, 6, 7, 8, and there weren't any on that one, so B is 8. And then we count up all of the interior points, which there's a bunch of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 9, 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 51. All right. So 51 interior points, and now I just got to plug them into my formula. All right. So A is 1/2 of 8 plus 51 minus 1. Well, half of 8 is 4. 4 plus 51 is 55 minus 1, and the area is 54 units squared. And wasn't that so much easier than doing that? Say yes. Yes, it was. It was much easier. So what I want you to do real quick, find the area of this. Pause the video. Here, I'll even do this. I'll even give you Pick's formula right there. All right. Use the formula and find the area. All right. Hopefully you all used the formula. Hopefully none of you took that and turned it into triangles and tried to solve all of that. That's what, 8 different triangles? No, that's a pain. We don't want to do that. We want to do the formula. So let's see here. Where are my boundary points? Those are my boundary points. And I have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boundary points. Should I do that down somewhere? That's not it. There we go. 15 boundary points. And then I want my interior points, which is 14 interior points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we plug it in. So we have 1/2 of 15 plus 14 minus 1. Well, half of 15 is 7.5. 7.5 plus 14 would be 21.5. Minus 1 would be 20.5 units squared. That is so much easier than finding all of those triangles, isn't it? All right. So Pick's formula is really cool for finding area on a grid. So just to review, area is the space occupied by a flat surface, a flat shape. Perimeter is the distance around it all. Perimeter is really easy, just add them all up. Area, you're going to have to use one of these formulas, unless it is a composite figure, in which case you're going to have to use 2 or more of those formulas. All right. And then there is, of course, Pick's formula, which is amazing. Okay, remember, B is the boundary points. It has to be exactly on those lattice points. It's just where it's on just where the grid lines cross. Okay, not using these points in the middle, not using any of those. Just where the boundary of the polygon actually crosses the intersection of the grid. Does not work if all the vertices are not on the lattice points. All right. Hopefully you found that useful, and I will see you in the next video.